In Unit 3, next topic is basic characteristics of controller. What are the basic characteristics? Normally, the intersection of two characteristics, point A, determines the mode of operation. Station 1 operating as a rectifier with constant current control, and station 2 operating at constant minimum extinction angle. There can be three modes of operation of the link for the same direction of power flow. Depending on the voltage of rectifier, which determines the point of intersection of the two characteristics which are defined below. So the first one is CC. So already I told that in equivalent circuit, normally in rectified side we can control the power by using alpha. In inverter we can control the power by using gamma. So basically there are two controllers, CC and CEA. CC is a constant current controller at rectified side, and CEA constant extinction angle control at inverter operating point A, which is the normal mode of operation. With slight dip in the AC voltage, the point of intersection drifts to C, which implies minimum alpha at rectifier and minimum gamma at the inverter. With lower AC voltage at the rectifier, the mode of operation shift to point B, which implies CC at the inverter with minimum alpha at the rectifier. Please observe the diagram. Controller characteristics. So drawn in between VD versus ID. DC voltage versus DC current. Voltage on y-axis. So here the points are A, B, C, D, and also E, F, G, H points are there. This is a IM point. So the type of station control characteristics are: in station 1, point A to B, B to C, and C to D. In station 2, HG, GF, and FE, reverse direction, HG, GF, and FE in station 2. In station 1, AB and HG, point AB and HG. Please see the point A to B and H to G is a minimum alpha controller. Minimum alpha controller. And also point BC, B to C, G to F. G to F is a constant current controller type. Next, point CD and EF. So this C to F is a CEA, that is nothing but constant extension angle control, minimum gamma. Here there is a minimum alpha, here minimum gamma. This is station 1 and station 2 controller characteristics. The characteristics AB has generally more negative slope than characteristic FE, because the slope of AB is due to the combined resistance of RD plus RCR, while is the slope of FE is due to RCI. So this is a power reversal controller characteristics. Power reversal means the power flowing from inverter to rectified side. VD, this is a ID. So current power reversal also possible normally. Power flow in reverse direction. The above figure shows the controller characteristics for negative current margin IM, or where the current reference of station 2 is larger than that of station 1. The operating point shift now to D, which implies power reversal with station 1 now acting as inverter operating with minimum CEA control, while station 2 operating with CC control. Already we observed that one in station 1 and station 2 characteristics. This shows the importance of maintaining the correct sign of the current margin to avoid inadvertent power reversal. The maintenance of proper current margin requires adequate telecommunication channel for rapid transmission of the current or power order. Voltage dependent current limit. The low voltage in the DC link is mainly due to the faults in the AC system on the rectifier or inverter side. The low AC voltage due to faults on the inverter side can result in persistent commutation failure because of the increase of the overlap angle. In such cases, it is necessary to reduce the DC current in the link until the conditions that led to the reduced DC voltages are relieved. Also, the reduction of current relieves those valves in the inverter which are overstressed due to continuous current flow in them. Please observe the characteristics: voltage dependent, current limit. So this is point A to B, B to C, C to C dash, C double dash. In reverse direction also D double dash, D dash to D, D to E, E to F. So this is a voltage dependent current controller. Voltage dependent current controller. This is I2, ID2 dash, ID1 dash, ID2, ID1 and ID. So this is a VD1 voltage, VD2. If the low voltage is due to faults on the rectified side AC system, the inverter has to operate at very low power factor, causing excessive consumption of reactive power, which is also undesirable. Thus, it becomes useful to modify the control characteristic to include voltage dependent current limits. The figure above shown shows current error characteristics to stabilize the mode when operating with DC current between ID1 and ID2. The characteristics CC dash and C dash C double dash shows the limitation of current due to the reduction in voltage.